For this video, we want to solve the system of inequalities given here. And by that, it means to find the graph of the solution set. So we want to find all the points that satisfy the first inequality, all the points that satisfy the second inequality, and where these points intersect, that region will be the solution. So we start off by first finding the boundary of each region. So for x plus y less than 6, notice it has less than note and that doesn't have the equals. The boundary for that one's going to be a line, x plus y equal to 6. Now for the second one, x squared plus y squared less than or equal to 4, the boundary would be x squared plus y squared equal to 4. That would be a circle centered at the origin of radius 2. So we actually look at the equations here. So for the first one, you just pick values. We want to graph the boundary for this one. Pick a value for x. It's x say 0. So we define the intercepts here. If x is equal to 0, y is 6. So the y-intercept is 0, 6. Replace the y by 0. We get x equal to 6. So this line passes through the point 0, 6. So let's say that's up here somewhere. And 6, 0 is over here somewhere. And the line passes through those 2 points. And notice I drew the line as a broken line or dashed line because the first inequality didn't have the equals. It was just less than. So we were just doing the first one. We would either shade everything above the line or everything below the line. A couple of ways we could do that. I always like to pick a test point, so you can pick any point that doesn't lie on the line. So we can pick, say, 0, 0, 1, 0, 6, and 6, somewhere over here. So let's just pick 0, 0. So put a 0 where the x is. So for the first one, my test point is 0, 0. Again, anything that's not on the boundary, in this case the line. So anything below or above. Plug it in. If you get a true statement, then all the points on that side will work. If you get a false statement, then it's the other side. So 0, 0 is below the line. Plug in a 0 where the x is, so 0 where the y is, and this was 0 then is what's less than or equal to 6. That's true. So for this one, we simply shade everything below the line. I'm just going to draw the arrows just to let you know where we're going. Now if this been a greater than or equal to 6, then it would be false, and we would shade everything above the line. So if you were just given the first one and asked to graph the solution set, you would just draw that broken line that I have there, and then you shade everything below. That would be your answer to the first one. Now for the second one, the equation was, or the inequality was x squared plus y squared less than or equal to 4. So we made it into an equation to get the boundary. And x squared plus y squared is a circle. The center is at the origin, 0, 0. And this is r squared here. So the center is at 0, 0. And the radius, in this case, would be the square root of 4, which is 2. So if I would come up here, say, from the center, I go 2 over over here, that's your radius. 2 up, and 2 down. And the second inequality did have the equals, so the boundary is included. So the circle would go like this. And there you have it. So remember, this initially was, this was less than or equal, and then this was less than or equal here. And let's try for the circle. Now, if you have a circle and you're doing the circle by itself, they just give you the second one and say, okay, graph the solution of x squared plus y squared less than or equal to 4. You pick your test point. Again, you can pick anything you want as long as this is not on the boundary. Just pick any point inside the circle or outside the circle and plug it in to the inequality. put a 0 there where the x is, 0 where the y is. I get 0 plus 0, 0 less than or equal to 4. That would be true. So you would shade everything inside the circle. Everything in here would be shaded. And that would be the solution for just the second one. Now we're looking for the solution or the graph of the system. So we simply shade the region that's common to both. So if I shade everything below the line, that's the solution set for the first one. Okay, this is coming down this way. And everything for the solution set of the second one, that would be everything in here. The intersection would be everything inside the circle. So the solution set would be this one right here. That's where the solution sets for each inequality intersect. So everything in here would be shaded. This is the solution set. Now if the second inequality only had the less than, all that means is don't include the boundary. In this case, the circle. But that is the solution set for the system of inequalities. Thanks for watching.